Hey guys, Mrs. Traver here. We're going to walk through factoring polynomials with grouping. In the last notes that we did it with greatest common factor. Today we're going to look at it with grouping with polynomials. So let's start ourselves off with example 1. So we've got x cubed plus x plus 3x squared plus 10x plus 30. Our game plan here, first off, always, is to look for a greatest common factor. So let's look through our coefficients first are 1, 3, 10, and 30. Since we have a 1, I know there's nothing I can pull out of all of them. Let's next look at the degrees. I have degree 3, 2, 1, and 0. Because I have a degree 0, I can't pull any x's out either. So there's no greatest common factor here. What we'll then have to jump to is just grouping. So look at the first two terms and the second two terms as separate pieces of things that we can pull a greatest common factor out of. So between the first two, we've got degree 1 and 3, coefficients 1 and 3, which there's nothing I can pull out there, but I do have degree 3 and 2. So the smallest of which is degree 2. Let's pull out an x squared. What's left on the inside of those two terms on the parentheses? Let's see, x squared times what is x cubed? I need an x. And x squared times what is 3x squared? I need a positive 3. For my second two pieces, 10x and 30, I can pull out a positive 10. And on the inside, I've got x plus 3. Now notice our x plus 3 is in common with both of these. So that's nice. We're going to end up having our final answer then being x squared plus 10 and x plus 3. All right, let's do another one. Here's our next one. We've got x cubed minus 3x squared minus 16x plus 48. Looking at first a GCF, none of these have something in common, so we'll have to move on from there. Our first two terms have no coefficients in common, but they do have at least an x squared as the greatest common factor. On the inside, what I'd be left with, x squared times what is x cubed? I need an x. And x squared times what is negative 3x squared? I need a negative 3. For my next two terms, 16 and 48 have a 16 in common. Because there's a negative on this first one, I'm going to use negative 16 to pull out, because I know that'll leave me with my first term being x, so that'll match. And then negative 16 times what is positive 48? I'd need a negative 3. Another way you can make sure you pull the correct term out is to just write your parentheses over here. You know you want it to match, and then find what you need. So from there, we can write our final answer. We've got x squared minus 16 and x minus 3. Let's do another. Before I move forward, I'd like you to try this one here, 3x cubed minus 2x squared minus 9x plus 6. Go ahead and do that now. Check your work with mine and see if that looks all right to you. Moving forward to our next example, here's example 3. We've got 2x cubed minus x squared plus 2x minus 1. So from this one, let's see, first looking for a GCF, the 2, a 1, a 2, and a 1. Nothing I can pull out there. Also, I have degree 0 here, so I know I have no greatest common factor from all of the terms. So let's look at groupings of them instead. The first two terms, we can pull out, let's see, a 2 and a 1. That doesn't help me, but I do have at least degree 2 in both of them. So I'll pull out an x squared. On the inside, I'll be left with a 2x and a negative 1. With my next piece, this is a good time to notice too, when you've got your first parentheses set, you kind of could just copy it over to the other piece, and then notice what do I have to multiply by in order to make that happen, which this is just the same, so I just needed a positive 1. We're going to do a couple examples, but 1 is what we'll pull out. And so it's kind of nice to think about that at some points, is that you've already got the parentheses set up here, and we need it to happen again. So what did that number have to be? So here we go with our answer. We've got x squared plus 1 and 2x minus 1. All right, let's look at this one. It looks a little bit daunting, but what's cool is we'll notice that it's actually not so bad, especially when we have a problem when there's huge numbers, it seems. We should be kind of leaning towards thinking about a greatest common factor. Scanning through our coefficients, 54, 90, 6, and 10, I noticed right off the bat, these are all even, which leads me to know I have a greatest common factor. So I know at bare minimum, I can pull a 2 out of all of these. And then our degrees, I've got 4, 3, 2, and 1. So at least I can pull out an x. That'll downgrade each of these by 1 degree and cut all of the numbers in half. So let's do that. Half of 54 is 27, and then I can go down a power. Half of 90 is 45, and down a power. Half of 6 is 3, down a power, and half of 10 is 5, and down a power. Now let's look at our new problem on the inside. Anything that we can do to factor out again. Maybe I didn't pull out the greatest common factor. What else could I pull? 27, 45, 3, and 5. Just noticing 3 and 5, those are both coprime. They're both prime, I should say, so therefore the whole thing is coprime. There's nothing I can pull out, and I've got degree 0. So from here, this piece of the problem is the same as the ones we've done above. So let's move forward with grouping our first two terms and our second two terms together. So we've got 27 and 45. I know I can pull a 9 out of those, and I've got at least degree 2, so there's an x squared out front. Drop down our 2x to hang out with us. What do I got here? In the inside I need, so 9x squared times what is 27x cubed? I need a 3 and an x, and 9x squared times what is 45x squared? Going from a 9 to a 45, I need a 5. So that one looks nice. Since I know my parentheses, just like I said in the last one, since I know my parentheses needs to match, I can just make sure it matches and then see what I need. So how did I go from negative 3x minus 5 to positive 3x plus 5? Well, I must have multiplied by a negative 1. That's helpful, especially in the 1 case. So both of these were cases with 1s. This one was a positive, this one was a negative. So the usual case is that you jump for a positive first, and then you would have noticed, oh crap, I don't have matching ones. I need to mess with it and change it to negative. You can avoid that little error in just copying over your parentheses if you want. So here we go. Throw another parentheses on to end this one, and then we are all set. So I've got 2x hanging out front. I've got a 9x squared minus 1 and a 3x plus 5. And we're all set. Those are as tricky as they get. I'd like you to try one more problem, though, before we go. So it is this one. Give this last one a shot. It is 3x cubed minus 6x squared plus x minus 2. All right, check your work with mine. This is one of those with a 1. You guessed it. There was no greatest common factor here, but if there was, we'd factor it out first. I think we'll call today for those notes, and I will see you guys next time.